All right. Well, welcome everybody to this month's Specifying Practice Community. So with that, I want to hand it off to Lewis and Elias to get started on horizontal waterproofing. I will be monitoring the question chats to help out with anyone that might have technical issues as we get going with the new system. So Elias and Lewis, over to you.
Thank you, Matt. This is Lewis. I'm coming to you from sunny Nashville, and it's actually fairly pleasant this week. It's the temperatures have been mild and the humidity's a little lower than normal. I'm going to introduce my friend and coworker Elias Saltz, who did speak with us, help us out last month with our presentation. And I've already forgotten what that was, of course, but
yeah, we talked about steel studs last month.
Oh yeah, steel studs, yes. Oh,
right.
Yeah.
So, yeah, I'm coming to you from the far-flung suburbs of Chicago, where it's actually also a really nice day, sunny. We had just enough rain earlier to tease the garden into thinking it was going to get some water, but not enough to really water it. And
Right.
So that, talking about water, maybe that leads us into our topic today, Lewis.
Absolutely. Well, except I wanted to remind the folks that Elias is an Illinois licensed architect, and he's been doing specifications for a long time, but he joined our firm just a few months ago as holding down the Chicago remote office. And he's quite a blogger. He blogs frequently, not only for Conspectus, but for the community blog Let's Fix Construction. And as Matt said today, one of David's daughters, Kim, has a birth scheduled, and we're waiting to hear about that. And so David and his wife had to drive to Delaware to see new baby. So.
Yep, I checked with the office just a few minutes ago, and they hadn't any news yet. So.
Okay.
So that's all we know.
All right. Horizontal waterproofing. Today we're going to talk about not roofing, but how do you waterproof horizontal surfaces that are above habitable spaces, primarily. And so that's
yeah, the spaces that typically may be occupied. The space above the waterproofing is going to be occupied as well as the space below it.
Yes. Yeah, these are not, typically a roof is not occupied as such, other than the occasional worker and persons looking for leaks. So there are a number of sections that are available for horizontal waterproofing. There's sheet waterproofing, and some of the self-adhesive ones are really good for David and I are working on a project in New York City where they're going to have believe it or not, a performance venue with wooden floors and an expensive grand piano for recitals. And it's something like 20 feet below the normal groundwater level. So we're going to have to build a boat down there, but it's not what we're going to be talking about today. And then we have the fluid applied. And Elias, you want to?
Sure. Well, so this is really mostly where we're going to be focused today. And so the types that obviously these are a number of types of products that are available. Most of them work extremely well for waterproofing of horizontal surfaces. In Chicago, hot fluid applied rubberized asphalt is probably the #1 go-to product. You know, obviously these things vary by market, but then the cold applied products are good if you're going to be working in a space where it's difficult to get the hot kettles, so the number of products that are available include them modified, unmodified polyurethanes, acrylics, synthetic rubbers, and the methacrylates.
Which can be a consideration if you're designing a terrace. I had a terrace that was up on the 15th or 16th floor about 3 years ago for a project in downtown Nashville. And getting a hot kettle up there was not overly practical. So that influenced this decision. So there are practical matters in addition to the cost that affect the selection. And if you are part of the selection team that's going to be choosing which type of waterproofing, you probably need to you may need to, depending upon the conditions, open up some dialogue with your manufacturer reps for 2 or 3 different types of waterproofing. We might also, I forgot to say that on the sheet waterproofing, that is commonly used for split slabs. And we'll talk about that later.
Okay.
Some more types.
Yep, so bentonite waterproofing essentially used the same way as the sheet waterproofing used in the last slide, except bentonite has the additional bentonite, or sometimes they use bentonite or a synthetic bentonite, which swells up when it gets wet and seals up all the little pores and nooks and crannies just through the swelling action.
So you wouldn't want to use this in a split slab situation because it does swell enough to lift or crack the wearing slab above it. So this is really only for
foundation.
Yeah, foundations, vertical foundations. And then we have the traffic coatings where we need a waterproof coating that can accept, that is suitable for direct exposure to pedestrians or vehicles.
Right. Generally, traffic coatings in this section are not UV stable, so you don't use them in areas where they're going to be seeing a lot of sunlight, but they can be driven or walked on directly.
Well, some of them are. Some of them are really good for pedestrian bridges, and of course you've got them listed for balconies too.
Right.
And they are waterproof. They're not maybe quite as waterproof as some others, but they work very well for their limited applications. Okay, so we talked about a little bit about installation considerations in terms of, one thing is, where is this in the building? Is this up on the 20th floor, or is it down below grade? Where do we need to put this thing is a prime consideration that we forgot to put on the slide. But another one is the waterproofing going to be exposed to sunlight? Because many types of waterproofing have cannot be exposed indefinitely to UV light. The long chain polymer molecules break down and become short chain molecules, which means they get hard and they get crack and they lose their elastomeric properties.
Yep, you don't want that to happen because then water can start moving its way through the system.
So, Elias, you want to talk to us about what do we need to look for in the concrete substrates?
Yeah, well, the main thing we put here right on the top is moisture. Moisture in the concrete can have a lot of bad effects on the waterproofing. Start with hot applied waterproofing. The hot asphalt is applied at up to 400 degrees. If there's a lot of moisture in the concrete, the moisture is going to boil and force its way through the membrane, thereby, causing weak spots. No matter, you put more coatings on top of it, it could continue to boil out and pockmark your membrane. Even the cold applied don't react well with moisture, and you can have weakening of the system just by moisture migrating up through the concrete and getting trapped underneath the membrane.
So in your specifications, we need to have that under the examination article in part 3 to check to see that the water that might be in the substrate is within the range recommended by the manufacturer.
Sure, and a few ways to do that are simply the sheet membrane. You tape it to the concrete and wait a while, see if there's if you see moisture under the sheet. If you're using a hot applied, you can actually put a little patch of the hot tar right on the concrete and see if it sizzles and bubbles. If it does, then you know that you have too much moisture.
And for your the other substrates, if you have wooden sheathing, think of wood framed balconies in particular on an apartment building or condo. And you would have the waterproofing on the plywood sheathing, and then a wear surface that's a decorative substance. So there again, wood, of course, is notorious for absorbing lots of water. So you need to check about that for installation. And then looking at flashing and detailing, if your project is very complex, we may want to consider a liquid applied product rather than having the workmen and workers, I should say, try to practice origami with folding sheet membranes.
Then we talk about texture. Oh, what were you going to say?
Texture, sure.
Yeah, you just want to make sure that your concrete is not too smooth where the membrane won't grab onto it. So a broom finished type texture is recommended, or if it's a previously poured slab that maybe it used to be a floor and now it's going to be a waterproof surface, shot blast it to give it enough grip on the surface. So Louis, we do have a question.
Yes. Okay.
So why does a hot fluid applied membrane require longer cure times than cold fluid applied membrane?
Well, actually, I don't know that they do. One of the interesting things about the hot fluid applied membranes, and particularly we're talking about rubberized asphalt, is that they stay gooey basically during the life of the product. That's kind of one of their selling points, is because it's self-sealing, that if something should happen, if there's some mechanical damage for some reason or other that actually penetrates the membrane, you can pull the nail back out and the stuff will self-seal. That was something that the old coal tar roofs were capable of doing, but they're seldom used today.
Right.
So it doesn't really, what it needs is you have to put something on top of it to be able to walk on it, because it stays somewhat gooey.
Right. Well, some of the cold fluid applied membranes are actually multi-component. When you mix them together, you start the curing process, especially the MMAs can be 2 or 3 components, and you mix them together, you have a very short time. You can between.
Well, actually, you can control the curing rate that way, but that is an issue. And I've had one contractor. It was a kind of a multiple work package project, and we were working very closely with the contractor in terms of selecting some of the products. And I had specified, because an inexpensive cold fluid applied polyurethane waterproofing for the vertical surfaces, because there really wasn't much danger of water getting into the building. And the contractor said, well, can we use self-adhesive modified bitumen instead? I said, yeah, that's more expensive. He says, yeah, but I can backfill the excavations the next day. I don't have to wait for it to cure. So that is a consideration. Good point. And then we talked a little bit about the intersections. Or if we got complex intersections with vertical walls, are they maybe they're circular planners that again, would be kind of difficult to do with a sheet goods. And then drainage. You've got to deal not only with the surface water, getting the water off the surface, but if water does get into a terrace assembly, how do we get rid of it? And Scott asks, do not most cold applied membranes meant to be exposed have a layer specifically meant for exposure?
We'll talk about that a little bit, about the types of membranes that can be exposed.
Right, because again, it's a matter of chemistry. What is intended to be, that will also, not only is it an exposure to the UV, but because these are horizontal surfaces, they have to stand up to foot traffic.
Right.
Whether it's a lady in stiletto heels, or it's a car, or in a case recently that I dealt with, a people mover train at an airport. And we'll talk about that in a bit, Scott.
Yeah.
Well, here we are, fluid applied waterproofing.
Right, so this is just, a few photographs of some of the type of irregular surfaces that with fluid you can detail much more easily than you can with a sheet if you had to cut and paste and put little strips together. And just by going over all of the little corners and reinforcing it with some of the scrim material that they give you, you can waterproof a complicated shape like a stairwell. And you can see on the walls, they just go up the wall a few inches and then stop, and it's flashed. You don't have to worry about reglets or other types of metal flashing. It just self-terminates. And then with expansion joints, you can follow the expansion joint system. You put the expansion joint in and waterproof over the edge of it, and that's essentially all you need to do in that instance.
Okay, and we hope that they come up with some means of this on the stair of, I suppose they're going to put on some stone treads and risers, or maybe precast, and we hope that they cover up that ugly black stuff on the vertical wall.
Right. Well, especially since it looks like it's exposed to UV, so it pretty much has to be.
That's right. So, split slab, boy, this is an old technology that's been around for probably 100 years, and it's very common for plazas and bridge and driveways, and sometimes you run into it, as I mentioned earlier, with this project that we've got where we have to build a boat in the basement, or we should say we're building a basement boat to seal against not only water but radon, methane, and so forth. And there are different ways of approaching this. The hot fluid applied asphalt is not as common for split slabs, but cold applied polyurethane or rubber is common, and as are self-adhesive sheets. Because you can roll them out flat, they're a lot easier to control than trying to fox around a lot of complex details. But if we're just putting out large strips of sheets, one of the self-adhesive modified bitumen membranes will work just fine for that. Gail Golstead asked, is fluid applied more expensive than sheet? That depends upon what you want. The hot modified rubberized asphalt is probably the most expensive type of waterproofing that you can have. But because it is the self-healing, as we mentioned earlier, that's its selling point. It is a Cadillac system, so to speak. And am I showing my age by saying Cadillac instead of Lexus or something? Then the spray applied like a polyurethane waterproofing that you see, especially on vertical walls, which is really, it's, you know, one of the advantages is you can just go in and you can spray large areas very quickly and cover it. Is probably the least expensive type of waterproofing. And then the self-adhesive sheets are somewhere in between. And I don't know how to compare the exposed waterproofing sheets that were fluids applied waterproofing that we're going to talk about in a minute with any of those. Do you have?
Yeah, I mean, there's so many different ones. It's a hard question to answer, and it depends on each application, you know, what the application is and the size of the area. I mean, it's one of those questions that it's, you know, it probably depends on where you are in the country too, and what people are what the contractors are used to working with.
That's very true. Very true. Okay, so you want to say anything about the split slab? The nice thing about the split slab is that your slab up on the top, you can be exposed aggregate. It can be a base for tile or other surfacing, and can be quite decorative.
Yeah, why don't you go to the next slide, because we have,
okay,
you know, it's,
well, that's right.
Yeah, so this doesn't show exactly, I mean, the cross section appears to show pavers. It could be concrete because there's no pedestal shown, and on the right you could consider that maybe to be like a stamped concrete instead of stone, you know, instead of concrete pavers. Ooh, thanks. But it's just showing that you're essentially your main point of drainage is for a split slab is the top surface of the top slab. And so if you see can you go to the photograph which shows the drain sump, or just zoom out a little bit? And then any water that gets past the top slab, so most of the water is going to go through that drain, but then you also have a drain level at the bottom where the waterproofing is. The waterproofing ties into the bottom of the drain so that the drainage layer that's on top of the lower slab will allow any water that gets past the top slab into the drain.
And what I was trying to zoom in to show was this multi-core molded plastic drainage panels to allow the water to go sideways as much as it wants. And those are available in various strengths so that they're quite structural in terms of supporting the 100 pounds or even higher than that pounds per square foot load that's on the actual walking or vehicular surface. And like Elias says, that this way you have kind of a belt of suspenders. You know that probably 90% of the surface water or more is going to drain into the top of the drain. But if you get a little bit, or if you have excessive condensation, it can collect it down below. Now, most split slab situations, the upper slab is just poured directly on the membrane, which acts as a bit of a bond breaker, yes. The problem with that is that if you get some cracks in that topping slab, where does that water go? Well, theoretically, it's probably not going to go through the waterproofing, but if it gets in and soaks into the concrete, then with the freeze thaw action, you might get some damage to that topping slab. So that's a consideration.
Yep, we get one question from Gerhard Guth, who asks, who typically installs the drain? I would expect the plumbing contractor typically to install the drains.
Yes, but, and also your plumbing engineer is the person that needs to be specifying that drain. So if you're thinking strategically about a system like this that has sub drainage as well as surface drainage, you do need to coordinate that with your fellow plumbing specifier as well. Make sure that we get the right kind. All right. And then we can raise that walking surface up higher with these nifty pedestals.
Yeah.
They have a screw action.
Right. And most plaza decks that have pavers are going to be built on these on pedestals for the most part. I mean, you could always say most, but the ones that we see typically are pavers on pedestals. And
right.
The advantage is that the water is going to obviously flow between the pavers, and having it be held up above the surface of the stuff down below means that the water will have some place to easily flow. Normally you'd have, if there's going to be a occupied space below, you'd have the waterproofing with a protection layer and the drainage course and then insulation, and then the pavers would sit on top of that. So the pavers have these nice flared bases so that they don't crush the insulation.
Right, and you can see those spacers in there that help maintain the exact spacing so that you can have open joints, and so each joint is a drain rather than having to have a separate drain cast into whatever paving system we have. And then the most common, of course, is precast concrete, and you can get those manufactured in standard sizes and colors. There are a couple of manufacturers that make tropical hardwood like Ipe that is naturally rot resistant, and they assemble them into square panels that, again, they install very much the same way. And there are even some manufacturers that have very strong and extra thick porcelain tiles that you can get some juicier colors and patterns like that. So what kind of
membranes? Yeah, well, I think hot rubberized asphalt is mostly what you see. You could use typical roofing systems. We've seen PVC roof used underneath a protected membrane with pedestals. I would think that you could use a cold fluid applied as well. I don't normally see those used with pedestal systems.
So one of the nice things about a system like this is that the actual waterproofing membrane is protected not only from physical damage, but from ultraviolet light. Not much is going to get down to the surface. And even then, as Elias has said, by the time you get insulation on it, because you need continuous insulation if you have a habitable space below, and a filter fabric or something on top of that, there's UV is not an issue.
Yep. One consideration with the slab beneath a paver system like this is that I have seen, and it's not necessarily recommended, but I have seen dead flat slabs being used in this situation where the sloping for drainage is actually done by tapering the insulation. So any water that gets through the pavers lands on top of the insulation and then is directed on the slope, just rolls down on top of the insulation to find its way to the drain. Of course, any water that does make its way between the boards of the insulation is going to be sitting there on top of the waterproofing, but the waterproofing manufacturers tell me that that's so incidental that it doesn't even make a difference. Even though they say that, it still seems to me to be better practice to try to slope the slab beneath the insulation, because you just don't really want water sitting on that slab forever, especially if it's going to have a chance of freezing.
I thought of another advantage. I just now thought of it, is that one of the issues that we have with roofs is leaves blowing through the air and stacking up and clogging drains, the field type drains. And I've been on some roofs where I look around and I can't see tree one, and there's a pile of leaves 3 feet deep in the corner. So because those joints are going to be 1/8 of an inch or so wide, you're not going to get much debris that gets through that could clog a drain. But again, the pavers are just held in place by gravity, so it's very possible for the maintenance folks to be able to pull one up and clean out the drains if necessary.
Oh, sure. Well, Gerhard Guth asked, what about utilizing a drainage plane panel above the waterproofing at a dead level surface? Well, I think that's, if you have joints between the pavers, you're only going to collect as much water as landed on the pavers between those four, that goes through the joints between those four pavers. That's the only area that the drain is going to pick up. So the drain in that instance has to be at the waterproofing level.
Gerhard, I think what you mean is that what we were talking about is with this kind of arrangement, you can use tapered insulation to get the proper slope to get rid of the water. Not that it stays level, because you always need to have slope to get rid of water. And so the advantage, though, is that in many cases, it's easier to build the structure flat, or level, I should say, and then get the slope by tapered insulation. The same thing with roofing. So there's really no advantage to trying to put a separate drainage plane below. Okay, we're moving on here. And there are, of course, vegetated assembly roofs that Elias knows more about than I. Green roofs.
I do. Oh, okay. I don't know if that's necessarily true, Louis.
And really, this is kind of a roofing situation, but rather than a true horizontal waterproofing as such, because
yeah, typically you're not going to walk on top of the green planted material. But protected roofs with vegetated assemblies often have paved paths that lead in between the green areas. So the assembly is really pretty much the same. You just have a couple of extra layers built into it because you need to protect the membrane from the roots that grow through. So you basically have a root layer, but other than that, and maybe a filter fabric to keep the growing media from getting through to the drainage part, the drainage element.
Yeah, clogging drains.
But other than that, yeah, it's either roofing or it could be cold or hot applied rubberized asphalt, and then you build your green assembly on top of it.
Finally, we get to our exposed waterproofing for pedestrians or vehicles.
Right, which really gets closer to being roofing, but given the amount of traffic that you might have on it, and we sometimes see parking garages with the waterproofing that's going to end up being exposed. Or one project that I was not involved with, but I visited, is across the street from Wrigley Field. Some of the rooftop clubs have basically just a membrane with a little bit of texture in it, and that's the wearing and the waterproofing surface. And they used a methacrylate for that product, for that system.
Yes, and like parking garages, sometimes the top deck may be treated with that, although it's more common that it's just treated with a water repellent. But it can be, or if they're critical places where, like the access ramps or something might go over some inhabited or habitable area, then definitely you want to have something pretty serious to keep out the water. But so here we're talking about a face sealed system. And what are our options on that, Elias?
Oh, well, the face sealed systems that we're talking about here, generally it's the PMMAs, the polymethyl methacrylates, or the polyurethane methacrylates, and those are the ones that are long-term UV stable. You can color them, you can add quartz or crushed up walnuts to the top layer to give them a little bit of grit, so that if you're walking on and they're wet, they won't be slippery. So those are the typical ones that you see for heavy traffic that's going to be exposed long term. Traffic coatings can also be used, and those are typically not as flexible, but still good waterproofing systems as well. Or if you're not going to be walking on
typically a polyurethane system.
Yep, or a polyurethane with epoxy layers as well sometimes.
Yeah, the thing about that you want to think about with an exposed membrane is you need a certain level of stretchiness in case you get some micro cracks or movement in the substructure, because that's always an issue. And then the difference between pedestrian and vehicular is sometimes just a matter of thickness. But if you think about the amount of stress for a membrane when you have a heavy car that's turning its wheels, that's actually quite a bit. And so you have to have a very, very tough membrane that resists abrasion as well as standing up to UV and keeping out the water.
Yep, it's a pretty big ask, but they're using these methacrylate products for that application, and they do hold up.
The most recent project I'm familiar with using that is a couple years ago. I was at my previous firm. The firm was designing an addition to an airport terminal in Florida, which is notorious in South Florida, notorious for having very heavy rains when it does rain. And part of the terminal was there was a station at the top level for the people mover trains that are rubber tired trains that run on a concrete track. And so I was a little surprised. I thought that they would go with a split slab situation, because part of for the track that was over the actual occupied terminal, there was another track on the other side that was out over the sidewalk, so to speak. But no, they decided to go with the PMMA, and as far as I know, it's working just fine. So, but it is all of those systems are maintenance systems because they are unprotected. Eventually, they can wear, and so it's something that an owner has to consider, is that how often are they going to have to get in there, clean the membrane, and then add another layer?
Yeah, that is something that we haven't really touched on. Just in terms of a split slab system, it's pretty much impossible to maintain it. If it leaks, you have to break up the top slab, expose the membrane, and then repair it, and then pour a new slab. With a protected membrane with pedestals and pavers, it may be just a matter of removing a few of the pavers and making whatever repairs you need. So, although criteria that you need to take advantage, right, think about.
But obviously, the protected membranes are going to be less subject to any kind of damage than ones that are exposed to the wind and the rain and
Traffic. Yeah, sure.
So we get around to specifying field quality control testing in part 3. Now our old friend, the flood testing, this is the ASTM standard for that, and it has certain limitations. People used to do occasionally specify this for roofs, but the standard actually says it's really for waterproofing installation over habitable spaces or on elevated structures, but not intended for building roofing systems. One of the limitations of this is the idea is that you block the drains, you fill it with water, and then you let it sit for a day or two, 24 to 48 hours, to see if you look at the underside to see if you can see any signs of leakage. A couple of limitations. One is you may not have good access to the lower surface to be able to look for those things. The other one is that according to this standard, the maximum depth is 4 inches. So that's at the drains. If you have a 1/4 inch per foot slope, which is again the maximum slope mentioned in this standard, the amount of water that's out at the edge may be only 1 inch or less deep, and it may not be deep enough to provide enough pressure to actually find the leaks. So it does have some limitations, and people realize that. But so more recently, we've come up with electronic leak detection, and there are 2 types. One, there are 3 or 4 types that are specifically for entrapped water. If you already have water in the system, and usually this is limited to roofs, and you got some leaks, or there are signs when you're walking around, you hear squishing in the insulation, you know you have water that's trapped in the system, and there are ones for that. But then there are systems for checking the discontinuity of membranes that are good for new membranes. And Elias, you want to talk about these 2?
I would be happy to, Louis. So essentially they're both under the category of electronic leak detection, ELD. Essentially the membrane is non-electrically conductive. This is in broad concept, we're talking. The 2 systems essentially use the same concept, just use slightly different method to locate the leaks. But the membrane itself is it's an electrical insulator, but water is electrically conductive. So what they do is with the low voltage EFVM, they put some water on top of the surface, not enough to flood it, but just enough so that there's kind of a continuous layer of wetness.
A film.
But a film of wet, yeah, a film of water. Thanks, Louis. They put an electrical charge into the water, and then if they look for locations where the water is basically it's making a circuit with the material that's below the membrane. And if they find that some of the electricity is missing, so to speak, they find out where the short circuit is with the ground, and they locate the leak that way. So with the EFVM system, you put a coil along the edge of the roof. If you're putting a vapor barrier beneath the membrane, which you would for a roofing system, not necessarily for a waterproofing system, you would have to put a mesh of conductive material beneath the membrane, between the membrane and the vapor barrier, because the vapor barrier is also non-conductive. It's also an insulator. With the high voltage spark testing.
Oh, and
go ahead.
The EFVM doesn't work with EPDM roofs.
Right, because they are also conductive.
They're conductive, yeah. Carbon.
hmm
Okay.
And then the spark test works in a similar way, except without the coils. It's just a person walking around with a kind of a broom device that has electrically charged tips, and if there's any of the current goes to ground, then it has to have gone through a leak or a discontinuity in the membrane.
Yeah, I like the nickname for this system, the electric broom system.
Right.
Because it's the tool is looks like it's, I don't know, 14, 16 inches wide, and it looks like it's a steel brush, basically.
Yeah.
And you go around and you sweep. And one of the advantages of it is that you can sweep it on the base flashing on the verticals and find problems with there as well as on the walking surface.
Mm-hmm.
So those are your opportunities, and you just need to again think about what works for this project with the type of membrane that you're using.
Yeah, I actually had one rep recommend recently that you can actually use a combination of the two. Flood test only around the drains. So you dam up, close up the drain, dam around it. Not sure, he didn't tell me how big an area, but I would say a couple of square feet. Flood that, because if you're going to have a leak that's going to be found in a flood test, it's probably going to be around the drain. So then you would flood test that and then use the ELD over the field of the roof, because flood testing probably wouldn't find a leak. If it does find a leak, it's just going to be too difficult for you to identify where the leak is actually happening. And it's probably going to be around either the drain or a transition anyways.
Yes, although if in all the cases we're looking at, all of the horizontal waterproofing is all fully adhered. So we're not talking about having a loose membrane where water, if there's a problem, hole or whatever, interruption in the membrane, water gets underneath it and then goes sideways and drips somewhere, which can happen with roofing. I did a forensic study for my firm in Memphis. The president of a major bank in that area had brought his own very expensive furniture into the office rather than just relying on the stuff that would be supplied to him normally. And he had a leak right in the center of his $2,000 or whatever desk. So I had to trace it backwards, and I got up above the ceiling, and I'm tracing it. It goes over to the wall. It's running along the top, the track of the steel studs, and then I tracked it back. There was a drip that was coming onto the top track of the studs from a duct. So I'm tracing the water along the duct. Anyway, long story short, the water was traveling about 40 feet and making 3 or 4 right angle turns and changes of planes just to be able to drip on the president's desk.
How lucky. So we have a couple of questions, if you mind.
But we were able to get it fixed.
Good.
Tightened up. So okay.
All right. So, Louis, I don't know the answer to this one. Is there an ASTM or other number for the electric broom test for the high voltage leak detection?
I don't know that one off the top of my head, and I don't know. It may not. The problem with the electronic leak detection is some of the systems are proprietary, and so they're not covered by an industry standard. So I don't know if there is one. There may not be one.
And then Gail asks, do most owners actually do flood testing? And if so, do they use flood testing by an independent agency or by the contractor?
Well, that's it is very common for the contractor to just, you know, dam up the drains and get out there with some water and pour it to the right depth. And
yeah, it's not a sophisticated test that you need special equipment for. So sometimes it's specified that it's done by a testing agency just to make sure that it's done correctly, but it's easy enough.
And also an independent set of eyes rather than somebody who has a vested interest
Yep, right.
in the thing.
Mm-hmm.
Good question, Scale. Good question. All right.
Well, this is our last slide, Lewis. I had a really bad pun, and now I can't remember what it was. What was my really bad pun?
Well, I'm sorry. Well,
I have a leaky brain. That's not it, but it's pretty bad too.
I hope this session was of some use in terms of raising your level of consciousness about what types of waterproofing you need to do and what kind of questions you need to ask to pick the right product, because that's ultimately what's writing specifications is all about, is getting the right product on your specific project. There are no universal answers in the construction.
Exactly.
So, Matt, we'll turn it back to you. We're just a couple minutes early.
All right. Well, that's
almost used up the hour.
I was gonna say that's pretty awesome that we fit it on the time. I was a little nervous at the new system; we might fall behind. Well, as also, if there's anything about today's topic or about the system as a general you'd like for us to do, feel free to go over to the specifying community. For those that don't know, on CSI's website, which is just csiresources.org, we do have an open to the public community for specifying and the practice of specifying. Feel free to go over there. If you're not a member, it is free to join. Get on that and answer any questions or ask some additional questions or topics or share information you'd like to know about this topic or others directly in that community. Both Elias and I believe Lewis are on there, as well as close to 600 others of your peers. So there's a great way to get some additional questions and answer some information as well.
But no, thanks to everyone. We know that, you know, we appreciate that your time is very valuable, and we appreciate you joining us and hope that this is useful to you. And if you have subjects that you would like for us to cover, please let us know. You can send those to Matt or myself or David or Elias now, and we'll try to accommodate you. Thank you.
Thanks.